All right, section 6.2, bisectors of triangles. Our objective is to use and find the incenter of the circumcenter of a triangle, and use and find the incenter of a triangle. Okay, like hopefully you've watched the 6.2 exploration video already. If you have not, please push pause and go watch that. Okay, right. Okay, now that you've watched the video. Okay, if you remember in the video, we talked about 3 different lines all intersecting at one point. Okay, so if I had, let's say, this line and this line, let's say, intersect. Let's call this line M, this line N. So we have 2 lines, but for me to actually use the word concurrent, we need 3 or more lines. Let's call this line P. Okay, so when 3 or more lines, rays, or segments intersect in the same point. So here they all intersect at this one point here in the middle. Okay, this one point here, let's call this uppercase, I don't know, T, the name of that point. We say these 3 lines are concurrent. So we would say M, N, and P are concurrent. Okay. The point of intersection of the lines, rays, or segments is called the point of concurrency. So we would say lines M, N, and P are concurrent. With a point of concurrency is T. The point of concurrency is the point T. Okay, so there we have our point of concurrency is T. Okay, so if you remember in the video, we created the perpendicular bisectors of all the sides of a triangle. So here, let's go ahead. I'm going to, here, we'll use this triangle right here. Okay, so if I was to come in, I'm going to grab a different color just so we don't get mixed up, and draw in the perpendicular bisectors, okay, of each side. So I'm going to do my best to try to eyeball them. Let's say this one here is the perpendicular bisector. Again, perpendicular and bisector. Okay, and let's do this one. So we want to make a 90-degree angle. So they're perpendicular and bisector. And then we'll do this last one. Again, perpendicular, bisector. Okay. This point of concurrency right here. Okay. This point where all the perpendicular bisectors meet, we give it a special name. It's called the circumcenter. So the circumcenter is the point of concurrency of the perpendicular bisectors of a triangle. The perpendicular bisectors of a triangle. Okay, so we call that our circumcenter. Okay, so we draw in all those perpendicular bisectors. There we have the circumcenter. And so if you remember from, again, that exploration, what was interesting about this circumcenter is that circumcenter ended up being the same distance from all the vertices. So that's our circumcenter theorem. The circumcenter of a triangle is equidistant from the vertices of a triangle. So basically, if P is the circumcenter of triangle, in this case ABC, then the distance from A to P is equal to the distance from B to P, which is equal to the distance from C to P. Okay, so here we know. So basically, if these are our perpendicular bisectors, okay, if this is a perpendicular bisector right there, okay, so I'm going to highlight perpendicular bisector, perpendicular bisector, perpendicular bisector, which means each of these is 90 degrees, and it goes through the midpoint of each side. then we know these distances, the distance from P to A, is the same as the distance from P to B, which is the same as the distance from P to C. Okay, so that's our circumcenter theorem. Okay, so here in example 1, 3 snack carts sell frozen yogurt from points A, B, and C outside a city. Each of the 3 carts is the same distance from the frozen yogurt distributor. Find the location of the distributor. Okay, so this distributor then would have to be located where? If it's the same distance from each of these vertices, the distributor is located where? Is located at the circumcenter of triangle ABC. Okay. So then we would need to find all the perpendicular bisectors and go from there. Okay. All right, so in the exploration we talked about as you switch up these triangles, that circumcenter might or might not actually be inside the triangle. Okay. So sometimes if you have an acute triangle, then P is inside the triangle. The circumcenter is inside the triangle. Okay. If your triangle is a right triangle, then your circumcenter is going to be on the triangle and actually is located at the midpoint of the hypotenuse. At the midpoint of the hypotenuse. Okay. And if you have an obtuse triangle, then actually that point of concurrency or circumcenter is outside the triangle. Okay. So then what you can do is once you have that circumcenter, just like how it's drawn, once we have this circumcenter, I'm going to come in and I'm going to highlight circumcenter here, P, here, P, here, P. We can actually draw a circle that goes through the circumcenter, but that actually hits, if you notice here, this blue circle actually hits all 3 vertices. All 3 vertices of that triangle are on that circle. Whether it's an acute triangle, or a right triangle, or an obtuse triangle, all of those vertices are on the circle. Okay, so this is what we call a circle circumscribed about the triangle. So we have a circle that is circumscribed about the triangle. Okay, so the circle goes around the triangle, but all vertices of the triangle are on the circle. Hence those green points. They are all on the circle. Okay, our green points there. If all of the vertices of your, and it could actually, you could circumscribe about a triangle, you could also circumscribe around a square or a pentagon or any number of sides, but all those vertices have to be on the circle. Okay. All right, and so now we have a construction we're going to do. We're going to be circumscribing a circle about a triangle. So basically, I'm going to draw a circle around these triangles here. So to do that, first you need to find the circumcenter. So first, you need to find the circumcenter. And so that's these first 2 steps, is actually finding the circumcenter. But to find the circumcenter, you need to find perpendicular bisectors. So we're going to perpendicularly bisect the sides. So if you don't remember how to perpendicularly bisect, so I'm going to come in, I'm going to do some highlighting, I'm going to specify. So I'm going to look at this side AC. I'm going to ignore everything else about this triangle. I'm just going to look at that AC, that orange side, and I'm going to perpendicularly bisect it. Okay. So to draw the perpendicular bisector, I'm going to put my point at C. I'm going to stretch out farther than halfway. I'm going to do an arc above and an arc below. And then without moving my compass, I'm going to come over and do the same thing from A. Arc above, arc below. Okay, so now, and I'm going to actually use a pen just to color code things. So now I'm going to connect those two dots. My orange pen. So there, I have now perpendicularly bisected. This is 90 degrees and it goes through the midpoint of A to C. So there's one perpendicular bisector. Okay, but to find that circumcenter, I need to find the point of concurrency, so I need to do that again. So let's go ahead and let's do another side. It doesn't matter which side. I'm going to come over here. I'm going to do BC. Okay, so again, I'm now going to perpendicularly bisect that. So I'm just going to turn the page. I'm just going to turn it over. So I'm looking here at this pink BC. Again, I'm going to ignore everything else going on in this picture. And I'm going to come over. I'm going to put my point at B. That's way too far. We only want to be a little farther than halfway. Again, arc above, arc below. Okay, I'm going to come over, do the same thing from point C. Arc above, arc below. So where those two arcs intersect, that would be this point here and this point here. I'm going to go ahead and I'm going to draw in that. Again, I'm color coding just so we have different colors here. I'm going to draw that in. So there's my other. So this is perpendicularly bisects this side. Okay. So, but now you only really need to do two sides. We could come in and do the third, but if we do, it should go through this point, right? Because this should be the point they all intersect. So let's go ahead and let's mark this point here as point D. Right here. Point D. There is my, so what we just found here is the circumcenter. So that's going to be the center of my circle. Because now if I come in and put my compass at D, and we measure out from D to C, and then we measure out from D to B, and we measure out from D to A. Okay, if you notice, all of these distances are the same. D to B, and then over here D to C. So now if I draw a circle that goes from D to B, okay, and I don't change the size, oh, sorry, I'm caught, and just draw a big circle. I'm just going to turn my page. That's the easiest way to draw that circle. If you notice, now all three, oops, sorry, bumped, all three of those points, now point A, point B, point C, all lie on that circle. So now I have now circumscribed a circle about that triangle. Because to circumscribe a circle about a triangle, all the vertices of the triangle have to be on the circle. All the vertices of my triangle are there on the circle. So we've now seen how to find that circumcenter and circumscribe a circle using our constructions, our compass and our straight edge. Now we're going to go ahead and look at how to do it using coordinates, if it's on a coordinate plane. Okay, so here in example 2, it says find the coordinates of the circumcenter of triangle ABC with these vertices. So we're looking for those coordinates. So A is -1, 4. B is 1, 4. And C is 1, -6. Right about there. So here's A. Okay, so if we draw in this triangle, oh, I only need to connect the dots. What am I doing? A to B, B to C. Okay, so now what I need to do is I need to find the perpendicular bisectors of two of these sides, just like what we did here. We did the perpendicular bisector of two of the sides, okay, and then see where they intersect. But we're going to do that algebraically now instead of using our compass, okay? So I want the perpendicular bisector of two sides. So let's go ahead and let's do side A to C. So let's deal with side segment AC. So I want the perpendicular bisector of AC. So first of all, I need to find the midpoint. Okay, so first, if I'm doing AC, we're needing to find the perpendicular bisector. Okay, to do that, I need to find the midpoint. Okay, the midpoint of AC. Average the x's, average the y's. If you remember our midpoint formula, we add the x's, so we're going from A to C, so I'm using point A and point C here, these 2 points. So I take -1 plus 1 divided by 2, and then 4 plus a -6 divided by 2. So the midpoint, -1 plus 1 is 0. -2 divided by 2, -1. So 0, -1 is my midpoint. So there's my midpoint right there. Okay, there's my midpoint. We'll call it M. And then I want to be perpendicular. Okay, so to be perpendicular, I need to find the slope of AC. Slope of AC, it goes down 1, 2, 3, 4, 5, 6, 7, 8, 9, down 10 over 2. So, lowercase m slope, rise over run, down 10 over 2. So the slope is -5. So perpendicular lines have negative reciprocal slopes. So my slope would be a positive 1/5 is the slope I want to use. Okay. Okay, so then I know I want to go through this point and have this slope. So I would use y minus y1 equals m, x minus x1. So y minus y1, m 1/5, x minus x1. So then I'd end up getting y plus 1 equals 1/5 x. Subtract the 1 over, y equals 1/5 x minus 1. So there's one perpendicular bisector. So here, if I go through this point with a slope of 1/5, rise of 1, run of 1, 2, 3, 4, 5. Okay. Now here is one of my perpendicular bisectors. But that's only doing one of them. I now need to do another. Okay, that was just for segment AC. Okay, now we need to do this again for a different segment. So instead of AC, let's do another one. How about AB, this little guy. Okay, so now we're going to do the same thing for segment AB. Again, I'm still finding the midpoint. So from A to B, again, I would find that midpoint. So the midpoint, we'd go -1 plus 1 divided by 2, 4 plus 4 divided by 2. So -1 plus 1, 0 divided by 2, 4 plus 4, 8 divided by 2, 4. So 0, 4 is our midpoint. Well, right there. There's our midpoint. Okay. And we want to be perpendicular, but if you notice, this line is a horizontal. So if I want to be perpendicular, I would need a vertical. So my perpendicular bisector is actually going to be this straight vertical orange right here. So now we look, where does this orange line and this pink one meet? Well, they both go through point M. Okay, so that would be the point 0, -1. So 0, -1 is our circumcenter. Okay, is our circumcenter. Okay, now on to the next concept.